All right, going on to 9.7. It's entitled Pythagorean Theorem and its Converse. And we're going to be looking at an ancient Greek named Pythagoras. He kind of created this theory, and his theory relates to right triangles. So recall that right triangles look like this, and what makes them special is they have that right angle. And of course, a right angle is 90 degrees. And he was drawing these out in the sand, and he noticed something, that whenever you draw a right triangle, no matter the shape, no matter the size, but as long as it's a right triangle, and you name the sides A, B, and C, there's an interesting relationship that happens between the sides. Well, first of all, we call these just kind of our normal side. Now, there probably was an ancient Greek name that they called them, but I don't know what they were. But one name did stick around from ancient Greece. And it's this longest side that is always called C. We call it the hypotenuse. And the relationship that he discovered was that if you add the square of this side and the square of this side, it equals the square of this side. And if I write that out, it looks like this. It looks like a squared, the square of this side, plus b squared, square of this side, equals c squared, the square of this side. And it's pretty interesting how this works. We might go into a proof later. But we can use this relationship to figure out missing sides very, very easily. For example, let's take a look at a specific triangle. Let me build another guy down here. This is a right triangle of sides 3, 4, and x. Or in this case, we should probably call it C, because C is our hypotenuse in this case. Now, I realize that my right angle is not super perfect, but pretend that it is. Pretend that I'm an amazing artist and it looks great. So here we have our hypotenuse. So I can see that if I were to substitute in with my Pythagorean theorem, I could say that A, it doesn't actually matter which is which because they can flip around. My 3 squared plus my other side, my 4 squared, is equal to C squared. Okay, if I'm going to go ahead and simplify this to my next level, 3 squared is 9 plus 16 equals C squared. 9 plus 16 is 25 is equal to C squared. Okay. Well, we can actually use the property that we just learned the other day about how to solve this problem from here. To do this, to get rid of this squared, all I do is I'm going to take the square root of both sides. And this is one of the few special triangles that will give me a whole number for my other root, which is kind of cool. So this side, I get C, and this side, I get plus or minus 5, because whenever I do my geometry and I take the root like this, I always get plus or minus. However, I can discount my minus 5 as an answer in this case because I'm using it for geometry. So I can get rid of that minus, and I don't need to account for it because I can't have a side that measures negative 5 inches. It doesn't make any sense, and I can get rid of it in this case. So I can say that my C here is equal to 5. And this is a 3, 4, 5 triangle, and it is a very special case of Pythagorean theorem. Let's take a look at another example. In this section, you're always going to be finding the missing side of C, so it's going to kind of work out. Let's take a look at another example. Let's see, we have our sides. Let me see one that we can do. A lot of these are not what I'm looking for. Got it. Okay. Sides 3, 6, and C in this case, the unknown. Okay, let's use our Pythagorean theorem. A squared plus b squared equals c squared. I'm going to substitute in 3 squared plus 6 squared equals c squared. 3 squared is 9 plus 6 squared is 36 equal to c squared. 9 and 36 is 45. I hope, equals c squared. Now, to undo it, I'm going to take the root of both sides, and I get c, and the square root of 45 is about 6.70820, goes on forever. But because this is my geometry, I can go to tenths, and that's just fine. So I can say that 6.7 equals c. Now remember, this was plus or minus, but I am able to discount that negative root because I'm referring to geometry, so it does work. So my c equals, actually it doesn't equal, it approximately equals 6.7. Because I did do some rounding, so I should always use my proper form, and I should use my approximately equal to, my kind of wiggly equal sign. It's going to be much more accurate. All right, that's pretty much all you do in this section. You're going to do a lot of these to practice and kind of do that, and it'll be old hat by the time you're done. If you get stuck, ask a friend, ask an adult, or do some searching online. Good luck.